This is another question from homework number 10. It's a long one. The principle of redundancy is used when the system of reliability is improved through redundant or backup components. A region's government requires that commercial aircraft used for flying in hazardous conditions must have two independent radios instead of one. Assume that for a typical flight, the probability of a radio failure is 0.0027. What is the probability that a particular flight will be threatened with the failure of both radios? All right, so what we're really looking at here is the probability of a radio failure. We're assuming that if a radio fails, that is not a good situation for an airplane. And so what governments require is that you put in two radios because you decrease the chances of a failure if you have two radios. You have that backup. All right. So what we're going to be looking at is really how much, what is the difference? Is it worth it to put in that backup radio? So in this case, we are looking at the probability, or what we're given here, the 0.2007, is the probability of a radio failure. Call that F, probability of event F, which is the radio fails. We're told that probability is 0.0027. So that's already a very low percentage. It's much less than our 5% rule. So it's already an unlikely event that even one radio would fail. But let's see what our improvement is. So now we have two radios. So the question is, what is the probability that two radios will fail? So again, that's like an and. First radio fails and the second radio fails. We have to think of it like two events. So in fact, what we're going to be doing is 0.0027, which is the probability the first one will fail, times, because this is an and, a intersection 0.0027 is the probability that the second radio fails. On your calculator, you can type it in that way, or you can also use 0.0027, and using your exponent button, you can square it. It's the same thing. When you do that on your calculator, what should pop up is 0.0000729. So look at that difference. That is approximately 0.0000729%, and that is significantly less than this. So when they ask us to describe how the second independent radio increases safety in this case, I will let you use your own results here, your own decision as to which letter to put. But to me, it looks like a pretty significant decrease in the chances of both of them failing. I think I'd feel much more comfortable flying on a plane with two radios rather than just one.